technical questions posted. Um, I think they are selected from this bookstore, edition 6 or 7, I'm not really so sure. But apparently there's not going to be any solution for those questions. So work on them and then enjoy office hours. Peter's office is room 530 something, Jeffrey Hall. And then if necessary, I'll sit at the help center math department if necessary. And then email us if you don't know the answer to the questions. We'll do our best to provide the answers. What else? By the way, who is taking APSC 142? Everybody. And whose instructor is Behnam? You know, the Iranian guy. No one? Everybody has with Maureen? Okay. I was going to say he's my friend, so I'm not going to say that. Yeah, okay. Andrea and I will do our best to post online questions. So the thing is that you have two types of online questions. One is just to practice. You can solve it and see the answers to. And then the second type is going to be something like your homework, that you have to work on them and then you have to submit them. And we are working on some strange scenarios that if you don't like, you know, if even for homework 1, there are going to be 3 types of homework 1. If you don't like the type 1, you can try type 2, and then if not, type 3. And we are working on it. Hopefully today we're going to be able to post some online questions. Not the homework, just the questions, you know, just to warm up. And well, I posted the second lecture on YouTube. The quality is not that good, but go to YouTube, and then you can just search APSC 172. Actually, I was lucky enough to create an account, apsc172@gmail.com. So just search, you know, APSC 172. The 4th or 5th. When I created it, it was the 1st, and then now it's just down to 5. Video is the lecture 2. Again, quality is not good. Give us feedback, like quality of video or audio or whatever it is. I'll do my best to fix it. Okay, example 1.5. Well, we solved it. Just 2 small, tiny little points. One is that, well, we said x is 3 times cosine, y is 3 times sine, right? Sine of t. And then it's good to say that t is such that t is always larger than 0 and then smaller than 2 pi, because you don't want to repeat one point more than once, right? Sine is like it goes up and down, right? So from 0 to 2 pi, you cover a whole circle. But if you go further, you're going to be repeating. You're going to be walking around that circle more than once, which is not good. So it's good to say that t is, you know, larger than 0 and smaller than 2 pi. And then the second part is asking actually for the resulting speed. I think you know the how to do speed and velocity. So it's just in terms of t. Find the derivative of x and y with respect to t, which is obvious. X prime, or the derivative of x with respect to t, or x prime, is just because it's 3 times cosine t. What's x prime here? X prime is given by, what's the derivative of cosine? It's minus sine, right? And what's y prime, which is dy to dt? What's the derivative of sine? Cosine. And then speed is the norm of velocity. So this is velocity, right? Velocity is given by x prime and y prime. And then speed is given by square root x prime squared plus y prime squared. If you work it out, you'll realize that the speed is actually 3, because sine squared plus cosine squared is 1. Remember, sine squared plus cosine squared is 1. So x prime squared is going to be 9 times cosine squared. Y prime is 9 times sine squared. You factor 9, you will have sine squared plus cosine squared, which is 1. And square root 9 is 3. Right? Clear? As mud. So, example 1.6. Well, I explained a bit 2 days ago. What I said was, if you think about the projection of this curve, yes. Zoom. Better? Good. So, yeah, where were we? Oh, yes. So, example 1.6, if you want to write it. So, I said that, so there is this curve, and you think about the projection of this curve on xy plane, you're going to see a circle. And the reason is that, well, because of the equation, x is cosine, and then y is just simply the sine, right? So these together, they give us actually the equation for a circle. So if you look at it from the top, so the top view would be a circle. Then so usually I recommend figuring out a couple of points and then use them as a something like a hint. So let's pick T0. T0 gives you coordinates of this point. Cosine 0 is 1. Sine 0, 0. And 0 is 0, right? So this is the first point. And then let's increase T just slightly. If I increase T slightly, still I'm going to be on this circle, right? But somewhere like here, but there is this Z involved. So for any T, so here is like, again, I have cosine T, I have sine T, and then there is this third part, which is T, right? So again, projection is this circle, but I have to go up. So this is the second point for any T. So it's just like this curve winding around this Z, right? And if you, it's not really good, but if you look at it from the top, projection is always this circle, this dotted circle, right? So it just, winds around this Z circle, the Z axis, and this is the curve, right? So any point, again, projection is going to be a circle, but it just winds around Z circle, Z axis, and then goes up. So what's the slope? Well, a slope is defined as, it's a bit strange, but a slope is defined as Z prime divided by square root x prime squared plus y prime. And Z prime is dz to dt, and then y prime dy to dt, x prime dx to dt, right? This is the slope. It's a bit strange, but it is what it is. So it kind of physically makes sense. Well, z prime, x prime, y prime. Yeah, y prime, yeah. So this is x, and then y prime. So z, these primes, they are the velocity, right?
Do we have to know this?
Yeah. It was painful for me too. So x prime, y prime, z prime, they give you the velocity, right? So this is like the ratio of your vertical speed to the horizontal speed, right? Kind of makes sense. So, but it is what it is. Z prime divided by square root x prime squared plus y prime squared. So anyway, What's x prime? X prime is negative sign. What's y prime? Y prime? Y is sine of t. So what's y prime? Cosine. And what's z prime? Z is t. So what's z prime? 1. So it is just 1 divided by minus sine squared is just sine squared, right? Sine t squared plus, and y prime is just cosine t squared. And then we know that sine squared plus cosine squared is what? 1. So 1 divided by 1 is 1. And here's the slope 1. And interpreting t as time, find the velocity of the moving point in part A. Actually, we did it, right? We said that x prime is cosine, so we already did it. You just have to write it down again. So x prime is minus sine, and y prime is cosine. But the speed is, it's just the norm of velocity, which is sine t squared plus cosine t squared plus 1 square root. And then it's just 1 plus 1, which is square root 2. Right? Clear this part? Good. So 1.7, it's rather involved, and I believe this solution is going to be posted. So, but I'm not going to bet on it. So write down whatever I write, and then you can just recheck. So, so the question is that I am walking, and that I think it's the boss, Peter Taylor, walking on the hill. Z is 9 minus x squared minus y squared, and the projection of my path on xy plane follows the ellipse x squared plus 4y squared is 4. So that's that path. I kind of, it's not really visible here, but that's the thing. So again, from the top, if you look at it, it looks like this ellipse here. If you look at it from the top, but from the ground, it has this shape. So the question is, at what point is my path the steepest, and what's the slope of the climb at that point? Okay, when I first tried to solve this question, I thought that steepest is when z prime is max. But this is not the case. Steepest means the point that z prime divided by square root x prime squared plus y prime squared is max, or maximized. So this is the key. Please, if there is this midterm exam, final exam, online example, something, be careful. The definition of being the steepest is slightly different from what one may think. It's not only z prime. It's z prime divided by square root x prime squared plus y prime squared, right? Please pay attention. So this is a slope. If you only take z prime, it's going to be really easy, and the answer is kind of straightforward, and you're not going to, I think, any mark for it. So please pay attention and memorize this definition. The slope is z prime divided by something. So this is the basic thing. So let's first parameterize this equation, or this curve that we have. Following the same reasoning, if you remember last time I gave you, I talked about the like the thought process that gets you to that sine and cosine. You do the same, you're going to end up with this parameterization. So x is 2 times cosine t, and y is sine t. And then z is basically whatever it's given here, 9 minus 4 cosine t squared minus sine t squared. So I'm going to repeat it. So this second equation that I have is telling me that x squared plus 4 times y squared is 4, right? So think about what I said last time. So I started with x. I said that x squared can take on any value from 0 to 4. And so that means that x can take on any value from minus 2 to 2. And then I said that let's divide the whole thing by 2. And then x divided by 2 can take on any value from minus 1 to 1. And then bingo. This is the cosine function, right? So I have this part. I'm going to repeat it. X squared from 0 to 4. That means that x is between minus 2 and 2. And then x divided by 2 is minus 1 and 1. And then I'll get this one, 2 cosine. It's not a proof, it's just a thought process. But it's pretty standard. And again, you could have used sine, but it's just, pretty standard. For x, everybody uses cosine. I don't know why, but just we're going to use it. And if you assume that x is 2 times cosine, you're going to have y is basically sine t. And for z, you just need to use the first equation. Z is 9 minus x squared. So now I have one free parameter, which is t. And then everything is given in terms of t. So that's the curve that I'm actually, or he is actually walking. So next step is what? I have x and I have y, I have z. What's the next step? Derivatives. So x prime, y prime, z prime. What's x prime? X is 2 times cosine. What's x prime? Minus 2 sine of t. What's y prime? Derivative of sine is cosine. And z prime is derivative of 9 is 0. Derivative of 4 times cosine squared is, so minus 4 times 2 cosine t times minus sine t. Right? Oh, you can see. Minus derivative of minus sine squared is 2 times sine t times cosine t. Does it make sense? So I have cosine squared, right? This is the chain rule. If I want to find the derivative, right? The chain rule, so I have cosine squared. First is like 4 times 2 times cosine, and then the derivative of cosine with respect to t. If I simplify it, I'll have 6 times sine t cosine t. Right? Okay, let's use the definition of a slope. So slope is given by z prime, which is 6 sine t cosine t, divided by no, I have one minus here and I have one minus here, right? So minus minus gives me plus. Yeah, 4 times 2, and then I have minus sign here, right? So, and x prime is 4 times sine squared plus y prime, which is basically cosine squared. This is the slope. And I have to, so the objective is to find a t such that this slope is maximized.
In the first step, when you were just finding x,
Okay.
2 cos t, how did you know that x squared was between 0 and 4?
Yeah, using equation 2. You see x squared plus 4 times y squared is 4, right? 4 times y squared is always positive. It's always positive because it's squared.
Okay.
Okay, so now the next step is to find that unique t that maximizes this slope, because that was the objective, right? I just want to find this the point that I have the highest slope, or this steepest point. So I have to find a t such that this function is maximized. It's pretty much calculus 1, I believe. So I need a t such that this function is maximized. I'm just going to call this one f of t. So let's simplify it first. I'm going to write this function. Okay, just a small math trick. If I want to maximize a function, I'm actually here, I don't care about the slope, right? What I care is just the value that maximizes f. Actually, I can say that that t also maximizes ft squared, or f squared, because again, it's just a positive function, right? If you maximize a function f, let's say there is a t that maximizes f, that t can also maximize f squared. It's just easier. Why? Because because of this square root, I really don't like it, because I can do it. I can find the derivative of the whole function with respect to t, but the problem is that this square root is a pain in the neck, so I don't want to do it. So I want to work with this function f squared, which is given by 6 times sine t cosine t squared divided by 4 times sine squared plus cosine squared, right? Again, if I simplify it, it's going to be 36 s times 1 minus s plus 1 plus 3s, and s is just basically sine squared t. So how did I get it? I use this identity that cosine t is 1 minus sine t here and here. So here I have 3 times sine squared plus sine squared plus cosine squared. This part is 1, so you have this 1 here. And this 3 times sine squared, which is again here. And then cosine squared was 1 minus sine squared, right? So, and then I said that I'm going to denote sine squared by this s here. So I have 36 times s. Thank God. So 36 times s, 1 minus s divided by 1 plus 3s. So now the objective is to find that s that maximizes this function. So I'm going to call this function now g of s. And then how to find that s? You have to find the derivative of g of s with respect to s, and then solve this equation. Okay? So if you solve this part, you will realize that s can be either 1 by 3, or 1/3, or minus 1. So there is some work for you tonight. Just complete the steps that I'm not taking care of. So s is minus 3, or s is minus 1, or 1/3. Okay, just S cannot be a negative number. Why? Because as I defined S as sine squared. It is squared. It cannot be negative. So this is impossible. So the only acceptable solution to this equation is S is 1/3. Right? So this being the case, sine squared t is 1/3. That means sine t is 1 divided by square root 3. It can have minus plus here. And then that gives you cosine t minus plus 2 square root 2 by 3. And z, you can use equation 1 here. Z is given by 6. Okay. Okay. Let's recap. There is this slope that I want to maximize. I found the parametric equation for x and y and z, and I use this definition to find that function. The function of interest is now slope, and it's called f of t. Right? I did not like to work with that square root, so instead of maximizing f of t, which I could have, I just tried to maximize f squared. When you are at home, you can try working with ft. You will end up with exactly the same solution. Exact same solution. But it's just working with f squared is easier because it doesn't have that square root. So I worked with that function.
What was the cos of t step? The second last step.
Here?
No. Way down to the right. Under the sine, yeah.
Oh, because cosine t is square root 1 minus sine t squared plus minus, right?
Yeah. Okay.
Yeah, and for z I used equation 1. For cosine t I used this one. For sine t I just used this. Yes, sine squared plus cosine squared is 1, right? Okay, so you guys can use the f of t. I used f squared, and I wrote it in terms of sine of t. And again, sine of t was cumbersome. I just chose another notation. I said that sine t squared is s, and I end up with this equation here. I said derivative of g of s with respect to s must be 0 in order to find that s. And that gave me two values. One was negative, which was impossible because s was sine squared. Sine squared cannot be negative, right? It just doesn't make any sense. So s was 1/3. And back to the place that I defined s, that was sine squared. So sine squared is 1/3. And what's sine? It's minus plus 1 divided by square root 3. Second step, cosine, right? So I use this identity that sine squared plus cosine squared is 1. So I have sine, and cosine is minus plus square root 1 minus sine squared. So sine squared here is just 1 by 3. And then it gives me cosine t plus minus square root 2 by 3. And for z, I just use equation 1. So 95% done. We found x and y and z. And so the next step is to find the slope, right? So now, based on this information, these solutions that I've got so far, sine t, cosine t, z, I can find x prime and y prime and z prime. Why? Because I want to calculate this slope, right? Remember, the objective was this slope. This down slope, I need x prime, y prime, z prime. But so far, I only got sine and cosines. So you plug in this information that we got so far, you're gonna get you're gonna get slope So this is a slope. Is basically 2. Again, couple of steps I ignored. Please, you're gonna hate me for this, but please, when you're at home, write it down, write down the complete solution, because in your exam, you're expected to do so. So again, just to recap, you need to find this slope. A slope is defined as z prime divided by square root x prime squared plus y prime squared. And then first, you had to express this x and y's and z in terms of one free variable, which was t, right? So we did it, and we said that x is 2 cosine, y is 2 sine, sine, and z is whatever it is. And then we found x prime, y prime, z prime. The objective was to find t such that the slope is maximized. And again, because I hated to work with a square root, you can do it by all means. Instead of maximizing f of t, I decided to work with f squared. So I worked with f squared, and I ended up with this function g of s. And I tried to maximize it. We find the derivative equals 0, that gives you s. So sine of t was 1/3. From that point, you can find cosine t and basically everything. A little not easy. Clear? Any questions here for me? Any questions here?
What if you replace z prime with the slope exactly?
Z prime here. The slope is z prime, right?
What did you sub in z prime?
Excuse me, if there is a question, I can. So, how did I get this z prime? Is that a question?
What did you put in as
So, okay, z prime is this 6 times sine of t cosine t, right? Okay. And here I got sine and I got cosine. So you plug it back, 6 times sine cosine, you will have your z prime. And then you just plug it back here in that slope function. So this t that actually we found here corresponds to angle 60 degrees. But if you start from, again, you know, this definition for a slope is slightly different from what you may think. I originally thought that the slope is just z prime. If you do that, you're going to end up with angle 45. But if you use this definition, the angle is 60 degrees. So be careful. In your exam, a slope, use z prime divided by square root something, and not only z prime.
Bottom right there, you have z equals 6. You mean z equals prime because if you z equals 6, the derivative of 6 is 0, so that would set the slope to be true.
Well, z is 6, right? Yeah. And you said that if z is 6, and then what?
Well, the derivative of z is
Oh, no, this is the value of z when t is whatever it is here. It's just 1 point. I'm not saying that z generally is a constant, right? I'm just saying that for this given t, the value of z is 6, right? So basically, the angle is somewhere here, because I said it's like 60 degrees, right? So this is 60 degrees. So for this t, you will have x given by this, y given by this, and z 6. So I'm not saying originally z is always constant. Just at this point, elevation is 6.
Why are you supposed to pop value of z if you just go to
What if I?
So why is it important to pop the value of z when you just don't use the values of z prime, x prime, and y prime in this, like the equation from the slope? Or what point? Oh, okay, sorry. My bad.
Yeah, well, basically, I wasn't really interested in Z. Yeah, as you said, it's not really informative. Who cares about Z, right? I only needed sine and cosine. Why? Because this Z prime is just a function of sine and cosine. I only needed sine and cosine. Yeah, you're right. Z is not informative at all. I wasn't asked to find Z, right?
Yeah, it does ask what.
Oh, it does ask? Then
Yeah,
okay.
so-
Then it was necessary. Okay. So planes. Okay, most likely, as I said, most likely the solution to this 1.6 is going to be posted. 95%. So just to review a couple of concepts that you guys are already familiar with, and it's just going to be so boring, but it just takes 5 minutes or something. So dot product is defined in n-dimensional space. Either it's when it's actually one-dimensional space, it's pretty obvious, just the regular multiplication. Two-dimensional space, three-dimensional space, we have the u dot v here. So let's say u is a vector ABC and then v is x, y, z. So u dot v is given by a times x plus by plus cz, right? In four-dimensional space, you can work it out. Just element-wise, multiply the elements and then add them up. Couple of examples that it's really, really easy. This dot product has some nice properties. One of them is that dot product of sum is sum of dot products. So dot product of sum is sum of dot product. As you see here, w dot u plus v is just w dot u plus w dot v. And then it doesn't matter where you put that u or v, u dot v is exactly equal to v dot u. And then length of a vector, actually we have used it so many times so far, but just to review, right? So norm or length of a vector u is given by square root a squared plus b squared plus c squared. If it's a two-dimensional space, you don't need that c, so you can drop it. And then another example, length of this vector 1 minus 2 minus 3 is given by square root 1 squared plus something. It's easy. And then this is another nice property that u dot u gives you this squared, norm is squared. So you see here that u dot u is just a squared plus b squared plus c squared, which is the norm squared. Distance between 2 points. So generally, if you have, let's say there are 2 points, point A and point B, in the n-dimensional space, and you want to find the length of this vector that connects the two, or basically you want to say how far these points are from each other, you have to find the length of this vector, a minus b. This is the length. Distance. So distance of 2 points is given by, just basically you have to find the length of the vector that connects these two. For example, distance of these 2 points, 1, 2, 3, and 4 minus 2, 1 is given as such. Just to review, not difficult stuff. So there is another way for dot product to define it actually, but here we have a theorem to prove it, that u dot v is given by norm of u times norm of v times cosine theta, that theta being the angle between two vectors u and v. So this theorem is one of the nicest theorem possible. that says that if you have two vectors that they are orthogonal, their dot product is 0. This is really, really nice. So you can imagine that any two vectors that they make this right angle in n-dimensional space. We can imagine we don't have any problem with two-dimensional space, yeah, and three-dimensional space. But this is also true for n-dimensional space. So sometimes they use this dot form to just say that two vectors in n-dimensional space are orthogonal, because it's hard to imagine this. I think it's impossible to imagine. But when they say that two vectors are orthogonal, they mean that u dot v is 0. So it is very, very important. And then here's a proof to show that u dot v is normal of u times normal of v times cosine theta, theta being the angle between two vectors. And by the way, if this is a right angle, what is u dot v? So let's use this equation here. We already said that is 0, right? But why? That theta is what? 90. And cosine 90? 0. And that's the thing here. When two vectors are orthogonal, that theta is 90. Cosine 90 is basically 0. That's why the dot product is 0. So here's the proof. I really don't want to call it proof, but because the boss says it's a proof, I have to say it's a proof. So it starts with this thing that the length of u minus v, the difference between two vectors, we have two ways to say what the length is. The first one is just to start with the definition of dot product, right? Length of u minus v is given by u minus v dot u minus v. How did I get that from? Actually here. Here. U dot u is just this norm squared, right? So I use the same definition here. And I said that the same holds for u minus v. And then you work out the math. You're going to realize that u minus v squared, its norm squared, is normal u squared plus normal v squared minus 2 times dot product of u and v. And again, there is a second way to calculate the length of u minus v, which is given by this. U minus v norm squared is normal v squared plus normal v squared minus 2 normal v cosine t. And then these two are equal, then are these two, then that gives you this nice identity that u dot v is normal v times normal v cosine theta. I actually don't think it's a proof, but you may be asked in your exam to write down a proof, so here's the proof. Why is not? Because we kind of started from the answer. We said that u minus v is u squared plus v squared minus, this thing. There isn't any proof for this one, so I don't really want to call it a proof. So u dot v, just to wrap up, important thing that you have to actually memorize is u dot v is normal v times cosine. And an example, find a vector that is orthogonal to both u and v. The answer is given. I'll give you a hint here. So the hint is that let's call that vector that I'm looking for, let's just denote it by x and y and z. So I'm looking for a vector x and y and z such that it is orthogonal it is perpendicular to this u 1 1 1 and also to this other vector v 1 minus 1 2. So basically I'm looking for a vector x y z such that its dot product is 0. Dot product of x y z and 1, 1, 1, and dot product of x, y, z and 1 minus 1, 2 must be 0. So these two, they give me actually two equations. The first one is x plus y plus z is 0, and the second one is x minus y plus 2z is 0, right? I just used the definition for dot product. If a vector is orthogonal to u, then its dot product is 0. And if that vector is orthogonal to v, then its dot product is 0. So I just used this definition here, dot product 0, dot product 0. And then I ended up with these two nice equations. Let's say x is t, and then find y and z in terms of t. If you do so, you will have y is minus t divided by 3 and z is minus 2t divided by 3. How? Just, say here, if x is t and it's assume that it's just a given constant, then you have y plus z is minus t, and then minus y plus 2z is just t. But treat t just like a constant. Think that is 1, it's 2, it's whatever it is, but it's just a constant, it's not variable anymore. And you solve this, if you add up these two together, you're going to have 3 times z is equal to Did I make a mistake? This is minus t? Oh yeah, this is minus t, of course. Minus 2t. Just add them up, you're going to have this one. So z, and then when z is minus 2t divided by 3, use either the first one or the second one, you will get this identity for y. Clear? So dot product 0, I wrote down the equations, and I assumed x is t, and I figure out y and z in terms of t. So I ended up with this, right? So let's write it down in a different way. So x, y, and z are basically 1 minus 1 divided by 3 and minus 2 divided by 3 times t. So t can be anything. Not 0, anything. 1, 2, 3, 10, 1 million, 1 billion, or negative 1, whatever it is. And that's the vector. That's the thing that we were looking for. So any vector of this form has this property that it's orthogonal to both u and v. And that's all for today. Any question from you?